Today we're going to do a recap of what we did yesterday, and that is to talk about the applications of the statistical probability law. Now, what is this law that we did an experiment with? Who can remember? Yes, it's basically the idea that the more an event or activity, or a happening, and is repeated, the closer the average, the closer the average outcome gets to the expected theoretical idea, yeah? Gets to the expected theoretical result. And that's a lot to take in. Yes. And so, how do we apply this? Yeah. So, it would be useful to use this in an activity that we just did, and that is oh, and that is the flipping of one coin. And we're going to just talk about this for a while. Now, in this one, the flipping of one coin, as we've discussed in our previous lesson, what's the theoretical result? The theoretical result is always 50% head and 50% tail. That's the theory. Yeah, that's the theory behind the whole thing. But in reality, when you start playing this, yeah, you flipped it and it's a tail, and you flip it again, it's a tail. Yeah, those two consecutive really is, yeah, tails. But if you look at the result through repetition, yeah, let's look at some of your classmates' work. So you could see that the percentage goes to really, yeah, 57, 43, 62, like this, yeah. So 60, 40, it swings back and forth in the 60s and the 40s, yeah, to the, close to the 60s and the 40s. It's going to be like that, yeah. And it's the same with this other result here. So here the result swings to 70, 20, 60, 30, yeah. But if you keep repeating the same thing, so if you notice in here, yeah, it's 64% heads, then 35% tails. See, it swings to this, yeah, it swings to this. This is a whole swing. I should really do a graph on this in another video. But here, and all as you keep repeating, it should go closer to 50%. Yeah, so here for the after 25 throws, yeah, in here after 25 throws, you could see, yeah, that it stabilizes it towards 50%. Yeah, so the last one is 48% for heads and 52% for tails. But if you do that, if you repeat that, yeah, if you repeat that 1,000 times, right, you will get, yeah, a 50%, close to the 50% expected outcome. And so knowing this observation, yeah, because it's been repeatedly um, noticed, then this one becomes a law. Now, how do we apply it in a game? Yes. So essentially, when you play this game, yeah, you betting game, yes. If you lose, yeah, for example, you flip a coin, yeah, that's a head, and you flip a coin again, and it's a head. That means you're losing. Yes. Will you stop? The idea there is no, you don't stop, because by this law, yeah, you should get a tail. It should balance out as you keep repeating. So when you're losing in a 50-50 game of chance, never stop. Yeah, you have to keep playing. Yeah. You have to keep repeating the coin toss, and only then you have a probability of recuperating your loss. Now, so that is when you are losing. Yeah, when you are losing. Yeah, yeah. For a few repetitions, don't stop. And the only requirement for this is you have really time and capital to play. Never lose, in a way, a capital. And what if you're losing? Yes. Now, when to stop? So essentially, when to stop is really, I'm practicing my.
Oh, I thought you were talking to me. Oh,
So
hot water for the plant. Sorry.
so you have to know when to stop, because otherwise, you know, you have to make the decision. So when do you stop? Is when you are winning. You know, when you're winning. So it's, for example, yeah, when you have like consecutive, you predicted it's going to be heads 2 or 3 times in a row. After that, you stop. Yes, because that means when you win. Yeah, 2 or 3 consecutive times. Because if you keep playing, yeah, it will likely balance it out. So I hope that is really, really clear.
It is. I was going to get a coffee.